wasn't affecting anything. Now this track me.
Okay, cool, cool. All right, so now we're going to be looking at device management protocols. So these are things that we use to just basically just collect information, and then that information that we collect, we can use that to better manage the network. So all of what we're going to be looking at here now is about collecting information from our switches and our routers, and see how we can use that to better manage the network. So we have syslog, which is system message logging, which is really a way for the routers and the switches to log any messages that are generated to an external device. Right? So it could be a server. And then we have NTP, which is Network Time Protocol. So the NTP doesn't really collect messages, but it is always good to use NTP whenever you're collecting messages. It's generally a good thing to use, but it becomes more important if we are collecting messages. Um, and we'll talk more in detail about it, but just to kind of give you a quick synopsis. If we're collecting messages from multiple routers, um, and we set the clock on those routers, it is likely that they may be a little off, a minute off or some seconds off and so on. And so when the messages come in, it's difficult to order those messages in a chronological order to say which message come in first, because the times are not um, synchronized across the devices. So what NTP does is ensure that all the devices have the same time. Right? So it's like, you have a watch, you have a clock, you have your computer, you have your mobile phone, and when you look at all of them, the time is never the same on them all. NTP allows that time to be the same on all the devices. So that's how we're going to use NTP. Then we have CDP and LLDP. CDP and LLDP does the same function. The big difference is that CDP is Cisco proprietary and LLDP is open. It's an open protocol. So Cisco proprietary meaning CDP will only work on Cisco devices. Or if there are any other vendor products that Cisco might have, licensed them to use CDP. But LLDP will work on every product. There is no license to get it to use, because it's an open protocol developed by IEEE.
What the LLDP stand for?
Um, uh, I might have to tell you later. We could do a quick look up. It's link local discovery protocol. Yeah. Let's just make sure. I think link local discovery protocol. Link layer discovery protocol.
Okay. I assume the Cisco one is Cisco protocol.
Cisco discovery protocol. All right. So we're starting with the login situation. Now there are multiple ways of seeing log messages on our routers and our switches. So this image we're looking at, we're using a router as the, the device, but it could be a switch, it doesn't matter. So as you know, we could log into the router via the console. So PCA here is showing us that it is connected to the console. And then we could log into the devices as well using Telnet. So when we log in via telnet, it means we are coming in via some network connection, right? Like over the LAN or over a wide area. So that's what we're showing here. Now, if we are connected via the console, then in order to see the messages that are generated at the console, we would use this command, login console. Now, of course, this command is turned on by default, so we will always be seeing messages at the console unless we turn it off by saying no login console. At the um, terminals where we would have used telnet or SSH, right, once we are connected over the network to the router or the switch, in order to see the, the messages, we have to do two things. We have to say login terminal. This command, I think, have been deprecated, so maybe we can test if it still works. But the new command is login monitor. So in login terminal or login monitor, and that now enables the Cisco iOS, which is the operating system, to send messages to the terminal. However, it just simply enables the messages to go to the terminal. But in order to get the messages, every time you log in via a terminal, you have to use this command to be able to see the messages. You have to say terminal monitor and then terminal monitor on. Right? So terminal monitor on, and then you're able to see messages at that terminal. So the login terminal or login monitor just says the iOS is now enabled to send messages to the terminal via SSH or Telnet. But when you're actually logged on, you have to then say terminal monitor on. Get that?
Yes, sir.
Okay. Now, all other devices that are connected via network will not see any messages. So, the normal user's computer connected via the network ports would not see any of the messages being generated by the router or the switch. Right. So, there's another option. Well, come back here. All of these, right, are instantaneous, meaning you'll see the messages as they happen, and then those messages disappear. They are not stored. There's no long-term storage on the router, right? So if you come back a day after, they are not on the router. None of these. It's just for you to see at the time when it happens. Now, if you want to be able to store the messages on the router, you have two options. One is login buffered. When you use this command, login buffered, the messages are stored on the router itself. So the router has a little memory area called the buffer, and the messages are stored inside there. Of course, that's going to be fairly small, right? And if the number of messages exceed the storage area, then what will happen? The older messages are then overwritten by newer messages that are coming in. So you may still end up losing some messages if you only use the login buffer. The other option that you can use is login and then put the IP address of external server. Right? So this server now is not a part of the router, it's somewhere else. And you are saying to the router, send the messages to this server. So this is going to be our syslog server. So login buffer stores the messages on the router. Login followed by the IP address stores the messages on an external server. So on an external server, you're likely to have much more storage space, and so you can keep those messages for a longer time, and you can keep more messages. Now, the next part we want to talk about is how do we see these messages that are stored, the ones that are stored on the router and the ones that are stored on the syslog server. So on the router, so we need the login buffer to store them on the router. You see those messages by typing show login. So you log onto the router, go to privilege exec mode and type show login, and you see the messages that are stored on the router. For those stored on the syslog server, then the most common way is that you access the syslog server through some web interface. But that doesn't have to be. It really depends on the particular syslog server, right? So whichever vendor is providing you with that syslog server, they may have different ways of allowing you to see the messages. But the most common is going to be via a web interface. As you know now, web interface is one of the more popular things now, right? To view or access anything. Good so far?
Yes.
Okay. All right. When the messages are stored on the router, not stored, when the messages are being displayed from the router, the default is that you see the time. Right? So down here is showing what a message could look like, but the default is generally time that is here. This section is generally the time. If you don't want to see the time, and you want to see a sequence number. So a sequence number kind of give you an easier way of tracking it. So you know you can say this is the first message because it will say 000001, and you can tell the 11th message because it says 000011. So you can easily tell the order of the messages that are produced on the router. So you have the two options. You can either do the time or you can do the sequence number. Time is the default. But if you don't want it, then you say no service timestamps and it turns off the time from right here. And then you can say service sequence numbers and you will then see the sequence number. Let's do a demo. So let's get Packet Tracer up. Waiting on Packet Tracer to come up.
So the store with the date as well. Though.
Repeat the question?
It store with the date as well.
Yes, it stores the data as well. Alright, so I need to log in. Alright.
This is for the on the switch, right?
Yes, both router and switch.
Okay.
Alright, so let's pick our router. Alright, so I'm going to bring up our, well, first of all, let's turn on our messaging. As you see here, this is actually on another message. Right? So anytime you exit from configuration mode, it tells you that something was done, right? Configured from console by console. So it's saying any configuration that was done, it was done from the console and by whoever was logged in at the console. Um, so let's bring our switch in, and then we can see if we can bring up a port and then disable the port, and we'll see the message. Interface. Let's see. No shot. Alright, so we see a message here. Once I did the no shot, it says link number 5, well, not number 5, link 5 changed. So the 5 here is the severity level of the message. We'll talk about that in a little while. It tells us which interface, and it changed state to up. So that's what the messages look like. Now, right now, we're not seeing any time here. We have not set the time on the router as yet. So we're not seeing any kind of timing. But it would be right at this side to the left here. So that's what the messages look like. Alright, so those notification or severity that I was telling you about, that's what it is. That's what we're looking at here now. So let me just see. Right here, see this 5 that we have here. This
Yeah.
Yeah, this is the severity of the message, or the severity of whatever caused the message. Now, that's what we're looking at here. So the severity levels are 0 to 7, so 8 severity levels. They are named as well, so they are numbered and named. 0 is called alert, 1 is emergency, 2 is critical, 3 is an error, 4 is warning, 5 is notification, 6 is informational, and 7 is debugging. Now, the more critical or the more important the message is, the lower the number. So 0 is right. So
Yeah.
yeah. So 0 is the most important of messages that the router is going to be putting out. And then 7 is the least of the importance of the messages. Um, One other thing is when we ask the router to display or to log these messages, we will need to state the severity. Right? Now, let's say we said we wanted a severity of 2 to be shown. What's going to happen is the router is going to show the severity levels of 2, 1, and 0. So it will always show the severity level that you requested plus anything that is more severe. You okay? Right. So if we ask for severity level 5, it is going to give us severity level 5, 4, 3, 2, 1, and 0. the idea behind it is to ensure that the most severe messages are always displayed. Right? You with me on that?
Yes.
So 7 is what we call debug, meaning if you want to get a view of all the messages are coming out, so you can then use that to debug and find out what exactly is happening with the router or the switch. Then at that point you would normally request a debug. Now Cisco recommend that you don't turn on debug and leave it on running all the time because there are so many messages that are being generated that the debug can easily overwhelm the processor. Plus, if you're storing these messages on the router, then it's going to fill up that buffer area quite quickly. Okay? So, recommendation is if you use debug, it's just for the point of time where you're doing the troubleshooting. But once you finish with that, you turn it off. The other one is level 6, which is informational. So this is really just the router, the switch giving us some information, telling us what's happening. Then you have notification. Notification is like an update of something that has happened. Right? So it's these are considered normal messages, so they are not necessarily indicating problems, but just things that you need to be aware of. Now, the next set are considered impactful, meaning they will cause some kind of change in how the device is working, right? The impact that working process of the router or switch. So 4 is a warning. So the device is giving you a warning. 3 is an error. Right? So that it tells you that something wrong has happened. So one way to look at it is a warning is saying something could go wrong. And the error says something has gone wrong. With me?
Yes.
Right.
Yes. Just read it. Say warning and low impact tree.
Right. So in this yellow area, we have 3 of them inside there, and warning is the lowest impactful of the 3.
Yeah.
Right. And then error is the middle level within these 3, and critical is the highest level within these 3. Now the next one is emergency. So emergency and alert are considered severe. Right? So when you see these messages, it means you need to begin to try to resolve it immediately. So emergency, the system is unusable. So something has gone wrong, causing the system to become unusable. And then you have alert, which requires immediate action. So something that you have to fix immediately. So these are the message severity levels.
And this is when you're connected to that particular device, whether the router or the switch, right?
Right, but remember also, if you had sent these messages to a syslog server, you could actually see them even though you are not connected, but you would have been seeing them on the syslog server.
Okay. Okay. So if
Uh,
it's internet, if you lose internet connection on the router,
yes.
call on 01.
No, well, I saw in some cases you can change the severity level, but losing internet connection
Mm-hmm.
is, let's say, lose internet connection mean the port that has internet on it goes down. That's
Mm-hmm.
going to be considered normal. So it's going to be a 5.
Oh,
Yeah. But of course, as we say, we can change those severity levels.
okay.
Yeah. So if I go back to as you see here, when I shut down the port or bring the port up, it tells me severity level 5. So a port going up or down is severity level 5. Alright, so this is how we turn on the commands or turn on the features. So for the console, we'd say login console. Right? That's the command. Um, if we are not just turning it on, but we also want to set the level, so we say login console and we put the level name as in severity. Sorry, not severity. Alert, emergency. We can actually type the name, or we could just say login console 0 or login console 1 or login console 7. So we can use the name or the number, any one we choose. So if we look back here, so we could say login console critical or login console 2, whichever one we choose. With me?
Yes. Give an example of unstable.
Um, let's say we have a case where the the routing protocol is not functioning. So you have your routing protocol OSPF
Mm-hmm.
shutting down.
Okay.
Then at that point it could get unstable.
Okay.
Or the router fan has gone down and the router is now overheating.
Okay.
Yeah. So anything that can impact the entire router.
Yeah. Yeah.
Yeah. Alright, so we now have logging monitor. So logging monitor, if I go back up, remember I was telling you here it says logging terminal. So this is being deprecated. So instead of logging terminal, you could now say logging monitor. So logging monitor, or we could go further and say logging monitor and set the severity level, in the level name or the level number. And for those that we want to be stored on the router, we say logging buffered, and to set the level, logging buffered, level name or number. For those that are to be stored on the syslog server, we'll now say logging host and then the IP address or the host name. Now we have two ways of doing this, right? We could say login host and then put the IP address or the name of the device, or we could do it like just going back up like this. Just say login and put the IP address. Both of them does the same thing.
On the name is what kind of name?
So let's say that this server, let's say we had called the server syslog server. That's how we named it.
Okay. Okay.
So we'll put that right here. The only thing though, if we're going to use the name, it means we must have a DNS running on our network.
Okay.
And we'll need something to translate the name to IP address.
Yeah. Yeah. I was thinking that.
Right. Right. So login host and the IP address or the name. And then if we want to set the level, in this case now we say login track. and put the level name or the level number. Right?
Yeah,
Alright, so here is a network. We're going to use this network to talk about how the login could be set up. So we have a switch here, then a router. The router is connected to another router. We're simulating a wide area right here, and then we have a second switch. All of these devices, these four devices, we are sending the messages to a syslog server. So a syslog server here is 172.60.3.9. Alright, um, so this is how we'll do it. So this is for R1. So if we look back, this is R1. So this is the configuration in R1. So it's a login console, and this is going to be done from the configuration mode. Login console 7, and then login monitor debug. So the monitor now is for persons who telnet into the router, and then login buffered 4. So this is the messages that are being stored on the router, and then login host and the IP address. So this is the messages that are going to be saved on the syslog server, and then login trap warning. So we're saying only the warning messages and anything that is more severe that should be stored on the syslog server.
explain the seven console seven, right?
Repeat that.
The console seven.
Oh, this is the severity level.
And the buffer four is where you're gonna save.
No, severe. These are all severity level. So
Okay,
7,
okay,
debug, 4, and warning are the severity levels.
okay. So everything from, don't see everything basically then.
For the console, we'll see everything on the console. For
Oh,
the telnet, well,
yeah, yeah, I get it.
yeah, for telnet, we're going to see everything because debug is the same as 7.
Yeah.
For those stored on the router, it's set at 4. 4 is the same as warning. Right? If we no, yeah, 4 is warning. If we go back, right, 4 is warning. You seen it?
Yes. All
Right.
right, let me go back to the slide again. Get some clear.
Yeah,
All right, so the console will say everything.
correct.
All right, the monitor will see um forward and down.
No, the monitor will see everything.
Everything as well.
Yeah,
Okay.
because I going back up. Debug is the same as 7.
Mm-hmm.
Right.
Oh yeah,
Yeah.
is a four is a buffered. Okay.
Right.
Oh, so the buffered four is stored then.
Sorry, repeat that.
The login buffered four.
Hmm.
That's what's going to store on the device, on the
Yes.
server. Okay.
Right. So on the device, we're going to store anything that has severity level 4, 3, 2, 1, and 0.
Okay. Yeah. I get it now.
And similarly, for the syslog server, we're going to store anything with severity 4, 3, 2, 1, and 0. Because warning is the same as 4. Right?
Yes.
Alright, so the next step now is if we having configured that, if we wanted to see what was configured, then we would use this command, show login. So when we do show login, this is what the output looks like. It's going to be a long output, right? So this is just part of it, right? The first part. So it says syslog login, and it says that's enabled. Right? So we know that syslog has been turned on. It will give us the rest of this that says 0 messages have been dropped, 3 messages rate limited, and so on. So it's telling you specific about the messages. Now, what this means is that um, the connection, the network connection between the router or switch and the server could have experienced some bandwidth issue, and so some of the messages were dropped. They could not make it to the server. So it can actually tell you if that had happened. Then down at the lower part here, it says console login. So we know we are logging at the console. Level debugging. Remember we had set that to 7, which means debugging. And it says so far 45 messages have been logged. And then monitor login level debug. So this is going out to our terminals that are using SSH or Telnet. So debug for those as well. Buffer login. So this is going to store on the router. That's set to warning. I remember it had said 4, which 4 is warning.
Yeah. The XML, see, what's that?
So you can store the messages in different format. XML
Okay.
is a format that you could store them in. So they are normally just going to be stored as normal text.
Yeah, readable text. Okay.
Yeah. All right. So this is a continuation of the screen. Right? So we are only seeing the first half of the screen here. This is the second half of the screen. Right? So in other words, when you type the command show login, what you're going to see is this information right here plus this information over on the next slide. With me?
Yes.
Right. So now we're looking at the second half of the information. So trap login. So trap login is the part that is going to the syslog server. It says level warning. Right. So you know we're only getting 43210 as in levels. Right? And it gives us the IP address of the server. It tells us the port on which the the server is operating. So the server is operating on UDP port 514. Right? So that's the port that syslog operates on. UDP 514.
That's by default.
Sorry, say again?
That's by default.
Yes, that's the default port number.
514 UDP. Okay.
Yeah. And then finally, log buffer. So this is the amount of messages, or not amount of messages, the size of the buffer on the router. All right, so going back to configuration now, right? Because this slide here was just looking at um, a show command, looking at what was configured. Right? Now we're going to, at this slide here, we're going to be looking at the actual configurations that we would be doing on the router. So in this case, we're looking at um, turning an interface off. So we say we go to the interface and say shut down, and then we see this message here. Right? So it's similar message to what I had seen, except that when I did it, I didn't have the time, and that's because I have not yet set the time on the router. So we see the time, the this section here is called the facility. So in other words, it's saying are what is it that we are reporting a problem on, right? And we're reporting a problem on a link. The severe,
Hold on, lad. Hold on, lad.
yeah.
Start from the asterisk October, come across.
Okay, so this is the time. Right? So it just called time, but it's really date and time. So October the 21st. It doesn't tell us a year, so it's the 21st of October, and this is the time 24-hour clock. So 20 would be 8 o'clock in the night. This is 7 minutes past 8 and 7 seconds. So 7 minutes and 7 seconds past 8. Of course, it gives us the seconds down to the thousandth of a second.
Okay, come on, what the hell is that, you know?
Yeah, so it's down to the 1,000th of a second. So 7.244 second. So we have the date and time here. Then the next section is where we get the link here says the facility. What is it the problem is occurring on? Right? And it is happening on a link. What is the severity level? It is 5. 5 is notification.
Normal.
Yes, right. And then, and remember you had asked about if the internet goes down, and I said it's going to be 5,
Yeah,
right?
yeah.
Right, and that's assuming is the port of the internet went down, so it just sees that at 5, because it's just one port, right? Then what exactly happened, and some change occurred. So this is kind of a summary of the problem. Something happened to a link, the severity level is 5, and there's a change. Now we get further detail over here, which says the actual link is gigabit Ethernet 0/1, so we know exactly which interface has gone down. And then over here now, it tells us exactly what happened. It says change state to administratively down. So we have full detail as to what has happened. Make sense?
Yeah. So I want to see the administrative down, we know it's the engineer do it.
Yes, correct. All right, looking still at these messages. Um, so here is one where we're seeing severity level 3. So again, we get the time, then the facility, the severity level, and the shortened version as to what exactly happened. It's up down. So we know the state change. And then over here now we get the detail. The link is actually interface gigabit Ethernet 0/1. It changed state to up, right? And then over here we well, it's the same message, right? But well, let me not say the same message. The same event, but two different messages. Right? The first one here is reporting on the physical interface. The second one is reporting on the software on the interface. It's reporting on the protocol that is running on the interface. Right? So this is saying the physical interface has now come up, and then this one is saying the protocol that's running on the interface has come up.
So the severity tree is what that now?
It's about it's for the same event, the same interface that just come up, but
Okay,
it's the
okay,
physical interface.
okay.
All right, so let me kind of further clarify that. I'm going to get back to the all right, right here. And go enable. Let's say show IP interface brief. Let's widen this window. All right, so note the headings that we have right here. The first heading is interface. Next heading is IP address. Next heading is OK with a question sign. The next heading is method. The next heading is status. The next heading is protocol. You see those, right? Andrew?
Yes, yes, sir.
All right. So we're going to be concentrating on these last two, status and protocol. Right? I want to have both things on the screen at the same time. All right. Yeah, I guess the best way to try and get this done is to copy it and put it elsewhere. Because I want to have both things on the screen one time so I can um, show you exactly what I want to show you. All right. Good, good. You should be able to make out my notepad font, right?
Come on. Yeah, that's it.
All right, good, good. So remember now, we're only looking at the last two heading, these status and protocol. Right? So status is telling us the physical status, right? About the physical interface. And the protocol is telling us about the software that is running on the interface. So the software could be Ethernet, it could be HDLC, it could be MPLS, Metro Ethernet. That's the protocol that runs on the interface. Right? So, so this first message here is telling us about the physical, which is right here, status, just this. So the physical status has a severity level of 3, but the software on the interface have a severity level of 5. With me?
Yes.
Right. So when an interface goes down or comes up, we could possibly see two messages, one representing the physical status and one representing the protocol. The one for the physical status will have severity level 3. The one for the protocol will have severity level 5.
Okay, I think I get it. Is the actual brief down of the port?
Sorry, say again?
I think I get it. It's like a brief disconnect of the port. It recorded.
No, not that. All right. I'm going to go back to the router and I'm going to go back to packet tracer and I'm going to show you something. I'm going to bring another router in the mix. Um, so these routers don't have any serial port, so I'm going to I need to get some serial port in. So to get that, I'm going to have to turn off the router, right? So physical, turn off the router, and then um, these routers don't support serial ports. Hold on, no serial ports. All right, so can't use these routers. I'm going to find a different router.
Uh, No, like I was just talking about the severity tree.
Yeah,
Although you're in some configuration, it wrote a record tree because the port was down brief. That's what I'm saying.
no, but it's not briefly. It doesn't matter if it's briefly or not, as long as the physical port goes down.
Okay. All right.
Yeah,
Again.
yeah. So what I wanted to show you is the difference between the physical port and the software.
Okay.
Yeah. So I'm trying to find a router that has it's much clearer on the serial port. So I really was looking for a router that has a serial port or that we have the ability to add serial ports in. Alright, so we can do it with this one. So let me delete that. So I'm going to use two of these. Um, Need to add serial ports because they don't have any by default. So let's turn off the router and add a serial port. Okay, this one should do. Right, so we have a serial. This is the serial port right here. So let's turn this back on. Go to this router. Turn it off. Add a serial port. Turn it back on. Now we're going to connect the routers via serial port. So this is the cable for serial. Uh, Hold on there. Hmm. Why not seeing serial? Hold on, I'm not seeing the serial.
Turn about the switch. Turn about the router.
I turn it on.
Uh,
Yes, I did. I did. Hold on. Yeah, so the green. We should. Alright, hold on. Um, I need to turn it off. I'm going to change to a different serial connection with 2T. Alright, so let's go now. So serial 0 slash 0 slash 0, serial 0 slash 0 slash 0. So now I can log in. Then I say interface serial 0 slash 0 slash 0. And then say IPADDR 10.10.10.1 255.255.255.0 and say no shot. Do the same on the other router. Turn it on it. Interface serial 0 slash 0 slash 0. Then IPADDR 10.10.10.2 and then say no shot. Alright, so we should have the two routers with their interfaces up. Alright, so now I'm going to go back on the router and then DMV and I say show interface serial 0 slash 0 slash 0 and I get the output for that interface. So up here you see it tells me that serial 0 slash 0 is up. So this is the physical, right? Physical. Then it says line protocol is up. So this is the software running on the interface. Right? Now the software running on this interface is HDLC. We see it right here, encapsulation HDLC. Right? So we have the physical interface and then we have the software. Right? So I'm going to turn off the protocol on this side. Right? So I'm going to say config T and then say interface serial 0 slash 0 slash 0 and then no encapsulation. So I'm turning off the protocol. Okay. So now that I turn off the protocol, On this side, there's no um, protocol running. Well, let's verify. I just did no encapsulation. So, so EMD, I'm going to say show interface serial 0/0/0. Let's verify if the protocol is still running. Alright, so it says the protocol is still running. Um, let's do something different then. So I'm going to go back to the interface. Say interface serial 0/0/0, and then say encapsulation. And instead of HDLC, I'm going to say PPP. So I've changed it to PPP. Now, the reason I'm changing it to PPP is that two routers must be using the same protocol. Right? If the two routers are connected, they must use the same protocol. If they don't use the same protocol, the protocol is going to fail. So by changing one to PPP and leaving the other at HDLC, we should have a failure. And sure enough, look what it says over here. Line protocol and interface 0/0, change state to down. Notice, it's not the physical interface that has gone down. It's just the protocol. See it?
Yeah.
So the physical interface is still up. Right? If I go back and say show interface serial 0/0/0 and look at the top, it tells me serial 0/0/0 is up. So the physical interface is up. However, the software running on it is now not working. It's down. With me?
Yes.
Right. So for the software, we will get a severity level of 5. But if the physical interface goes down, then you get a severity level of 3. With me?
Yes.
Right. So when we do a physical turn off of the interface, then at that point we should see um, two messages. One telling us about the protocol, one telling us about the physical. The physical will give us a severity level of 3, and the protocol will give us a severity level of 5. Alright, so in this case now, using the same diagram, I'm just going to go back up a little. That's this diagram here. Right? OSPF as a routing protocol was configured on the two routers. So what they're going to do is to cause a failure in the routing protocol and use debugging to see the messages that are generated. So that's right here. So say debug IP OSPF hello. Right? It tells us immediately that the debugging is turned on, and then these are the messages that are generated. But notice here the message. It says, of course, after we get the time, the date and time, it says OSPF, which is the facility, what is having the problem. Then it tells us severity level is 1. Right? 1 is emergency. And then it tells us what part of OSPF is having the problem. It's the hello message. Huh? See that?
Yeah.
Right. So now we see something with an even greater severity. And then over here is the detail. It says receive hello from 2.2.2.2, which is in area, and it tells us area 0, right? And the IP address that it received it on. So that is just looking at a different message with a different severity level. These are the messages on the syslog server. So if you go to the syslog server now, this is what it will look like on the syslog server.
Yeah, easy, clear, readable text. Yeah.
Right. Um, okay. So this is how you set the time. Well, first you can set the time zone. So you say clock time zone EST -5. So that's Eastern Standard Time -5. Then you can set daylight saving time. So clock summer dash time EDT, which is Eastern Daylight Saving Time, recurring. So you're saying while Eastern Standard Time is what you're using, but you want the daylight saving time to come in every time daylight saving time should normally come in. You know, whatever those time of year are when daylight saving time would normally kick in. So this part is saying we want it to operate at that time. And then down here now we're actually setting the time on the router. So we say clock set, and we're using 24-hour time. So 20, which is 8 o'clock, 52 seconds, 52 minutes, 49 seconds, and then the date, 21st of October 2015. So we have set the clock here, and then we can do show clock down here to verify that it has actually been set. With me?
Yeah, I just realized we used to do this on the option 11 with Teams.
Yes.
Mm.
So that is how we would do our messaging. Now we're going to move on to NTP. So NTP, as I mentioned before, is a way of ensuring all your devices have the same time. Right? So NTP is really not a messaging system, but it should always be used whenever you're dealing with messages, because you want all your devices to have the same time. So NTP is a network time protocol. NTP is dealing with clocks. Now clocks are rated, and they are rated using something called a stratum. The more accurate the clock is, the lower the stratum number. So stratum 4 is a less accurate clock than stratum 3, and stratum 3 is a less accurate clock than stratum 2. And then of course there's also stratum 1. Okay? Now, when we say a clock is accurate, what do we mean? Right? Because we may say, well, yeah, every clock is keeping the time, so what do you mean by the clock is accurate? And the concept is a clock usually have a drift. So typically 60 seconds will make up 1 minute. Right? However, clocks may drift off a little, and so you may find that 1 minute is really 60.2 seconds and not exactly 60 seconds. And for another clock, it might work out to maybe 61 seconds happen to work out to a minute based on how that other clock is working out. So what you could find is you set two clocks and you set them to the exact time. Both of them you set them to, let's say, 2 o'clock in the day. So 2 hours, 0 minutes, 0 seconds, and you set both of them to that same time. However, half an hour later, because one of them is having a drift, one of them may be saying, instead of 2:30, it is saying 2:31, and the other one is saying 2:30. So that one didn't have any drift. Right? So these things happen with clocks. And this is why even when you set your clock, set all of them at the same time. So at some later date, you may still see them having different times because the clocks have drift. You with me so far?
Yes.
Right. Now, the higher the stratum number, the more drift a clock will have. So stratum number 4 is going to have more drift than stratum number 2. So what we do now in in the network is to use one of our router and set the time on that router and let that router feed the time to all other routers. By doing that, then we are not eliminating drift, but we are ensuring that all routers have the same drift. With me on that? That making sense?
Yes. Yes.
Right. So, in other words, if we set the time on router 3 here, and then let router 1 and router 2 get the time from router 3, then even though router 1 and 2 would normally have been drifting much further than router 3, because they are now getting the time from router 3. So every so often they are going to check in with router 3 and say, okay, what is your time now? And they are going to reset their time to match router 3. So we will eventually see all the routers in the network having the same time. Cool?
Yes. Yes.
All right. So to achieve that, we're going to choose one of our router, in this case router 3, and set it to NTP server, which means it is just simply going to be providing time to other devices. And we would have to set the clock on router 3. So we would do this process right here on router 3, set the clock on it. Right? So we set the clock and we tell it that it should be a NTP server. Then we will go to the other routers now and we will tell them to be NTP clients. So they now are going to be looking to the server to get the time from the server. Once we set them to the NTP clients, we don't have to set the time on them. In other words, we would not need to go through this process on the clients. Right? We do not need to set the time on the clients. Right? They are going to be getting the time from the server. With me?
Yes.
Right.
So question like,
Yeah.
could you also use an endpoint device as the NTP?
Yes, you mean like a computer?
Yes, a server computer. Yeah.
Yes, you could.
Yeah. Okay.
Yeah. Anything that is on the network can be used as a server as long as it has the functionality for you to turn on the server.
Okay.
So in this, based on this setup that we have here, what they have done is they have set up R2 as both a server and a client, and R1 as both a server and a client. Now this is a little tricky, right? Because if R2 is a server, it could be feeding time to R3. However, the trick here is to change the stratum. So we set R3 at stratum 2, R2 at stratum 3, and R1 at stratum 4. So because it's a low stratum, then it will always look to the higher stratum to get the time from. Right? And the term lower and higher there can be a little confusing. Right? The higher the number means the lower the lower on the stratum level that device is at. That makes sense, right?
Yeah, but that's with a logic in way and just say the bigger the number, the less accurate it is.
Yes, that is completely true.
Mm-hmm.
So this is how we do the configuration. So on R1, we say NTP server 172.16.2.2. So we're telling it where to get its timing from. We're saying look to a server that is at this IP address. Right? So this is an R1. Let's look back on the diagram. Here is R1 and 172.16.2.2 is the interface on R2. So we're telling R1 to get the timing from R2. With me?
Yes.
Right. Then the next thing we do on R2 now, so we go to router R2 and we say NTP server 172.16.3.3. So we are telling R2 that it should get its timing from 172.16.3.3. Let's look up on the diagram. Notice 172.16.3.3 is R3.
Yes.
So we're telling R2 to get its timing from R3. Look at the full network now. R1 is getting its timing from R2, and R2 is getting its timing from R3. Alright, come back to the configuration. On R3 now, all we did is say NTP master 2. So we're saying you are the master. You don't need to look to any other place to get timing. You are generating timing and you will only be generating timing. The 2 here is the stratum level. So we are telling it that it is operating at stratum level 2. Good?
Yes.
Okay. So once we've set the NTP on the routers, we can now take a look at what it looks like. So on R1, which is the client, we can say show NTP status. We should see it saying synchronize. If it don't get synchronized here, something is wrong. You have to go back and troubleshoot. And synchronize is saying it is now getting the timing from a server. It tells us the stratum level, so it's saying it is operating as stratum level 4, and it tells you which server it is getting it from, which is 172.16.2.2. We know this is R2. Right? And then it tells us the actual time right here. In fact, it gives us the time, the date and time is given to us in 2 methods. Right here, this is hexadecimal. So this is actually the date and time in hexadecimal. And then it gives us the date and time in human readable format. Make sense?
Yes. Yes.
Okay. And then it says clock offset. So it's saying this clock will drift by 0.986 milliseconds. So the offset here is the drift that this clock has. The clock on R1 has this drift. Right? However, so that drift is going to, sorry, every 2.46 seconds, it will do a check-in. Right?
Yeah, okay, okay.
So even though there's this drift, if it's checking in this regularly, this drift won't be an issue. The drift will only become an issue if for some reason it stopped checking in. Right? Now it will stop. It will not be able to check in if this link, let's say this link goes down. So R1 will no longer be able to check in. At that time, it will just continue to run off its own clock, and that is when the drift becomes an issue. With me?
Yes.
All right. So that's it in terms of how that NTP works. So this is R2. We can do show NTP associations. Right? So it will tell you this output is taken from, sorry, not, I'd said R2, still on R1. So previously, going back, previously what we looked at is show NTP status. Now what we're looking at is show NTP associations. So two different commands. So it tells us that the clock was taken from R1 and it is acting both as a client and a server. Um, the address that it's getting the information from is 172.16.2.2, which is R2, but the actual reference is R3, which is 172.16.3.3. So R1 knows that even though it's getting the time from R2, it knows that that time is really coming from R3. With me?
Yes.
Okay. Now if we do the same command on R2, notice right here we have the address 172.16.3.3. So R2 is saying it is getting the information from R3. Right? But notice this interesting thing, reference clock 127.127.1.1. Right? There is no such IP address. If we look back on the network, there is no such IP address anywhere in the network. Right? What NTP does is it chooses a loopback address on the master to represent the actual point from where the clock is being generated at. We could word this as the clock is given an IP address of 127.127.1.1. With me?
Yes, yes.
Right. Right. So on R3, which is the master, it tells us clock is synchronized. It is a stratum 2. The reference is 127.127.1.1. In other words, the actual clock inside R3. And then if you look down here, where is it getting the information from? It tells us 127.127.1.1. And then the reference LOCL, which means local. So it's saying this information is coming from locally, right here on this router. See that?
Yes.
All right, so in this case now, looking at a new scenario, what we're looking at now is what you had asked, if the clock could come from somewhere else. And in this case, we're showing the clock coming from a server. Now, this server could be anywhere. It could be inside your network or it could be somewhere on the internet. Doesn't matter. So what we have is two servers, we have S1 and S2, and these are going to be our NTP clocks.
Like
Now,
leaf and spine thing or something.
sorry, say again?
It's like a leaf and spine network.
Yes, yeah.
Okay.
Now, um, the leaf and spine is a terminology that is used strictly with Metro Ethernet though. So it's not normally used in other networks, but it's really more like a hub and spoke thing.
Okay.
Yeah. All right. So specifically for this diagram, what they're showing you is a set of servers that are called NIST. These are servers that are built by the US government, right? And those servers are freely available on the internet for use. So before I go further in this, I want to show you those servers. So if I go to my clock area, um, see the clock area. Um, 1 second there. All right. So you know when you go down to the your system tray on your computer to the lower right side of your taskbar, you usually see the time. You still with me?
Yeah, man. Yeah, yeah.
Right. And when you go down there now, you can do change time and date.
Right.
Right. So that's what I just did to get this window.
Okay. Yeah, I recognize it.
All right. So I'm going to click here, change time and date again. Um, no, not here. Sorry. At the top here, we have three tabs: date and time, additional clocks, and internet time. So over here where it says internet time is where we can use the list servers. So it says this computer is set to automatically synchronize with time.windows.com. In this case, I am using a NTP server built by Microsoft. Right? But I could use many others. So if I come down and say change settings, this is where it is. So if I click on the drop down here, you see I have several others to choose from. These are the ones that I've missed are the ones that are built by the US government.
Okay.
Right, so I can use any of these as the servers that will provide timing to my devices inside the network. Now, this is just a small set. There are a whole lot of servers on the internet. Many companies have their own, like Cisco might have their own, Google have their own, and so on and so on. So Microsoft is just giving us a small set here, but you know, and depending on the operating system you're using, you might actually see a larger list than what I have. Right. So those servers, coming back to our presentation now, those servers are Stratum level 1 servers. Right? So these are the most accurate of time servers. So if we set our thing to them, then our devices in our network now will experience very, very low drift. With me?
Yes.
Right. So what has happened here, we are in this diagram, we are going to set R1 and R2 to get their timing from server 1 and server 2. And notice we're doing our redundancy setup. So R1, we're going to set it to get from S1 as primary and then S2 as secondary. And R2, this router here, we're going to set it to get from S2 as primary and S1 as secondary. So if there's any kind of failure on one of these stratum level 1 servers, then we'll be able to still get timing from the other one. And if both of the stratum 1 servers fail, then at least our routers are running at stratum level 2, which is still fairly accurate. And those now can provide timing to the rest of the network, which is running at stratum level 3. With me?
Yeah, yes. I'm
Alright.
thinking I work about three or more time zone, right?
Yes.
So based on the time zone, does it matter or it just automatically sense based on the
They,
area?
well, at the stratum level is usually set to UTC, the Universal Time Clock.
Okay.
Right. And that is why, if I'm going to go back up in the presentation, and that is why we had to do this, because the time that is going to get from the server is
Okay,
going to be
yes.
UTC. So we have to tell our device now to pick a time zone, and then
Mm-hmm.
our device will, based on the time zone we tell it to pick, it will do its offset.
And that is calculated based on London British Standard Time.
Well, um, I know what you're saying, right? But we do not want to call it London British Standard Time. We want to call it a UTC, Universal
Okay.
Time Clock.
Okay, yeah, right.
Right. It is the one that we used to call GMT, but they have changed the name from GMT to UTC.
Okay, okay,
Yeah. So
okay.
yeah, it's really the same thing you're talking, right? But we don't
All
want to
right.
call it that.
Yeah, yeah.
Yeah.
I
Uh,
realize them is zero,
yes. Right.
Yeah.
So we don't want to call it London British Standard Time. We want to call it UTC. That's the official name.
Right, right. I get it. I get
The, the British people would love for everybody to call it London British Standard Time.
it. Yes, yes. Mm.
Alright, so this is the configuration we would actually do on the routers now. So we'd say NTP server, and then we say time dash A dash B dash nist.gov, and then time NTP server time dash A dash G dot nist.gov. So the first one that you put in is the primary, and the second one is the secondary. And then what we could do again to protect, notice it says here protect against failure, right? We say NTP master 7. So what this does, it says if there is a failure on all these NTP servers, then continue to run off your own clock, but you're running now at stratum level 7. Now this is a poor level to run at, but I mean we could have said stratum level 2, say NTP master 2. But the idea is you are telling your device to run at a certain stratum level so that it can use that level even if it is no longer getting timing from an external server. With me?
Yes,
All right. So um, before I talk about this diagram here, I want to go back up a little and show you something. On this diagram, if you remember when we were doing the commands, we would say NTP server and we put it to the IP address of a physical port.
yeah, yeah.
Right? Now, this can be an issue because physical ports can actually fail. Right?
Hmm.
And if this physical port fail, then there is no way for for R1 to get the timing anymore.
Yeah,
Right? Now, this particular diagram, there is only one connection, a single connection from R1 to R2. So, I mean, there's just no other option, right? But in a network, usually we have multiple ways, multiple ways of getting to another router, not just through a single port. Agreed, right?
yes, yes,
Right. So in that case, setting the server to the IP address of a single port is not the best option. The best option is to create a loopback interface on say R2 and then tell R1 to get the timing from that loopback interface. Now R1 has the option now of using any possible means on the network of getting to that IP address, that loopback interface. Because the loopback is a virtual interface. So any means possible of getting to the virtual interface will be used. And then what we would have done is safeguard our timing situation from a physical interface failure. That makes sense?
yes. Make a lot of sense.
Right. So that is what I'm going to show you in the next diagram. That's this one.
Okay.
Right. So if we're working on R1 and we're setting R1 to be the client, then we might not want to have it getting IP address from one particular interface because that interface could fail. Right? So we have the option of setting it to get timing from interface 1, interface 2, or interface 3. But any of them could fail. So the alternative is to create a loopback interface on this, a virtual interface. And virtual interfaces cannot fail. Right? They are always up. And then what we do is tell R1 to get the timing from the virtual interface. Make sense?
Yes, yes.
Right. So that's what we're going to do here. So we say NTP server. Well, this is showing you doing it from the physical interface, right? We're telling it to get from, well, sorry, NTP server 172.16.9.9, that IP address. But notice down here, we say interface loop 0, which is the virtual interface, and we give it that IP address of 172.16.9.9. So we are now saying to R1, get your timing from this IP address. And then R1 now can use any path on the network to get to that IP address. With me?
Yes.
Right. And then R2, which has that loopback interface, we have set it here to be a stratum level 4. I mean, we could have set it to be anything, right? I figure what is being demonstrated here is that we could use any stratum level we want. Because as we have seen it set to 2, we have seen it set to 7, and we have seen it set to 4, right? So this is really a choice of the administrator. Right? We choose what stratum level we want to set. Um, 2 is going to be the best one. Um, You will not be able to set your routers to stratum level 1, right? Because your router is not going to be that accurate. It just would not have such an accurate clock. So NTP master 4, and then you say NTP source loopback 0. So you're telling it now that use loopback 0 as the place to generate the timing from. Cool?
Yeah, yes.
Right. And then now if we use our show command, show interface loopback 0, say loopback 0 is up and it is a hardware loopback, and we get the IP address that is on it. The good thing about loopback interfaces, they won't fail. They are just always up. If they fail, it's because the router failed.
And spanning tree would not affect this.
No.
Okay.
All right, so that completes our NTP section. So we're now moving into CDP, which is Cisco Discovery Protocol. So um, we have, you know, this is kind of a deep point to start, right? So I'm going to use Pocket Tracer and show you the actual starting. If you're doing CDP, where you'd actually start, right? Rather than start where they start here in the slide. So it doesn't matter if you use a switch or a router. So enable. So CDP start um, from here. We can do CDP run, right? This is where you start. You have to turn on CDP on the router or R switch. So when you do CDP run, you have done a global turn on, meaning CDP now turn on every port on your router or every port on the switch. Right?
Yes.
Okay. Now you can go, so I'm going to do it on the router as well. Let's use this one. So at the end, say CDP run. Oh, sorry, wrong place. I need to say config t, then CDP run. So we have globally turned on CDP. After that, you can now say interface serial 0/0/0, go to any interface and turn on CDP on that interface by saying CDP enable. Right? So CDP enable only turn it on one interface. So you have to go to each interface to say CDP enable. But to turn it on the entire router, you have to say CDP run. With me?
Yeah.
Alright, so let's go to a different router now. And in this case, I am not going to say CDP run, right? I'm going to go to an interface and then just say CDP enable. Right? So no other interface will have the ability to use CDP, just the one that they have turned it on. Right? And I can turn it off by saying no CDP enable. If I wanted, go back to this one, I can turn it off on the entire router by saying no CDP run. So CDP is not working on the router at all. Okay?
Like serial zero is right. Once you turn it on, that's the only one that will run on, right?
Yes.
Ah, yeah. Okay.
Yeah. All right. So when CDP is on, so let's turn it back on. CDP run. We can we can get the status by saying show CDP, and it tells us CDP sending CDP packets every 60 seconds. So it's going to be sending the Cisco Discovery packets every 60 seconds. They have a hold time of 180 seconds, and it is using version 2 of CDP. So there was an older version, but we're using version 2. So every 60 seconds, it's going to send out the CDP discovery packets. In other words, to try and discover other Cisco devices on the network. Whatever information it gets in that discovery, it will keep that information for 180 seconds. If it doesn't get an update within 180 seconds, it discards that update and says that the device that it had gotten the information from initially no longer exists. Make sense?
Yes. Question like, is there a disadvantage or advantage of turning it on serial zero or the whole server, the whole router?
Yes. So it's really a security issue. Right? CDP allows persons to be able to, if anyone connects to your network and collects those CDP packets, they can actually use that to draw a diagram of your network, learn the IP addresses of your devices, learn what is a router, what is a switch, learn the operating system versions of your switches and your routers, the name of the devices, a whole lot of information can be gathered. So it is recommended that if you are not using it, you should turn it off.
Okay.
And then if you want to use it only in a certain area, then turn it on only in that area because it can be a security risk. Plus, and from a network utilization point of view, there are advantages to keeping it off as well. Because here we're sending these packets. Every router, every switch on your network is going to be sending these packets every 60 seconds. In other
Yeah.
words, every minute. So
Yeah.
right. So that's using up the bandwidth of your network.
Mhm.
Right. So if you turn it off, then you reclaim that bandwidth. So one is from a network utilization point of view, and the other is from a security point of view. All right. So we have some other options. So we could do show CDP entry, show CDP interface, and show CDP neighbors. Those are other commands that we can use. Right? Now this leads us back into our slide because this is where the slide starts. But I needed to show you this other part first. Cool.
Yes.
So show CDP neighbors. What this does is it will give you a list of devices that are physically connected to the device on which you run this command. Now, it is important to note that CDP only collects information from directly connected devices.
So hold on, like, that's a similar to the MAC address table.
Um, no, because the MAC address table, yeah, because it says directly connected. Why are you thinking of that?
Yeah, yeah.
No, because a MAC address table is not only for directly connected devices, you know.
Okay, yeah, yeah.
A MAC address table is for um, any device on the network, on your local LAN that you are
Mm-hmm.
communicating with.
Yeah, yeah.
So it don't have to be directly connected, as long as it is on your LAN.
Mm-hmm.
Yeah. But let's look at, I'll go into a network to show you what we mean by directly connected. They're far way up here. This network is a good one. So let's take R1. R1 is directly connected to R2. So R1 is able to collect CDP information from R2. It will never be able to collect CDP information from R3. So using CDP on R1, R1 will never know that R3 exists. Right? It cannot use CDP to learn of R3.
Okay.
It will only know that R2 exists. However, as a network engineer, once you learn of R2, say you get connected to R1, you learn of R2, then what you could do now is just telnet over to R2 and then collect the CDP information from R2. In that way now, you would learn of R3. With me?
Yes.
Right. So that is the key thing. CDP only um, collects information on directly connected neighbors. And CDP operates at layer 2. So it doesn't operate at layer 3. It's going to collect layer 3 information, but it operates at layer 2. Right, so show CDP neighbors. Right? So we could just type this show CDP neighbors and it will give us a list, right, of the neighbors. Well, it's basically a one-line summary of each neighbor. You could go further with the command and say show CDP neighbors type number. Right here is the actual interface. So you could list an interface and it will tell you what neighbors are connected to that interface. With me?
Yes.
So if you just do show CDP neighbors, it's going to give you all the neighbors. But if you do show CDP neighbors and then put an interface here, then it will give you just the neighbors on that interface. Alright, so you could also do show CDP neighbors detail, in which case now it works similar to show CDP neighbors, but instead of a one-line summary, you're going to get a much more information, right? About 15 lines describing each neighbor. And we could also use show CDP entry. Now, show CDP entry works the same way as show CDP neighbors detail. Right? But with show CDP entry, you have to specify the name of a neighbor. And then in that case, it's only going to give you the detailed information on that one neighbor. With me?
Yes, yes.
So we're going to use this network to see how CDP works. I see we're at 303. Yeah, I don't know if you want us to break here and then come back and finish and go the next 2 hours to five, or you want to
That's
continue?
all. Now let's take a break.
Okay, so we're doing what, 10 minutes?
Yeah.
All right, so we come back at 13 past 3.
Okay, no problem.
All right, cool.